Hi learners, welcome back to DHILK. In today's video, we are going to understand an important reaction from carbonyl compounds, aldol condensation and cross aldol condensation. So we will cover what aldol reaction is, its step-by-step mechanism, and what is cross aldol condensation, and how to predict products with examples. So make sure you watch till the end and don't skip any parts. Okay, so let's get started. So before we move to aldol and cross aldol condensation, one important point that you have to know is that if in a carbonyl compounds, if there is an alpha hydrogen, what is alpha hydrogen? Let's see, RCH2, CHO. So carbon atom attached to the carbonyl carbon is the alpha carbon, and the hydrogen atom attached to that carbon atom is known as alpha hydrogen. So if in a carbonyl compound, if there is an alpha hydrogen attached to the carbon next to the carbonyl group, then that hydrogen atom is acidic. That is acidic. Why this hydrogen atom is acidic? This is because of the electron withdrawing effect of the carbonyl group and resonance stabilization of the enolate ion formed after deprotonation. So what does it mean? In alpha hydrogen, so I'm just representing this alpha hydrogen here. This is acidic, means that it is easy to break this bond and form H plus ion. So why this is happening? Because the carbonyl carbon, this CO carbon, this is carbonyl carbon. So this carbon atom is electron withdrawing group. Okay, this is electron withdrawing group. It has the electron withdrawing nature, and because of this electron withdrawing nature and because of resonance stabilization of the enolate ion. What is enolate ion? So after the removal of proton, it will produce a nucleophile, that is enolate ion. We can look at the structure. If you remove an hydrogen proton from this CHO, you remove the proton, then it will have a negative charge on this carbon atom. This is enolate ion. Okay, this enolate ion has a resonance stabilization. You can look at these resonance structures. This is a carbonyl compound. Proton is removed from here, so that it produces the enolate ion. So it can undergo resonance. So these are the two resonance structures of enolate ion, and because of this resonance stabilization, the removal of alpha hydrogen is feasible. Okay, so because of this reason, alpha hydrogens are acidic. Now we can go to what is aldol condensation. Aldol condensation is a reaction in which aldehydes or ketones having alpha hydrogen react in the presence of a base to form beta hydroxyaldehyde or ketone called an aldol. Okay, so what is aldol condensation? Aldol condensation is that condensation between two aldehydes or in between two ketones. Okay, and what is the condition? They must have an alpha hydrogen. What is alpha hydrogen? The hydrogen atom attached to the alpha carbon. What is alpha carbon? The carbon atom which is next to the carbonyl carbon. Okay, so if there is an alpha hydrogen in aldehyde or ketone, then it can undergo aldol condensation in presence of a base. So look at this reaction. This is a aldehyde, CH3CHO. So 2 moles of aldehyde. So aldol condensation will happen with the same compound. Okay, so for example, CH3CHO, ethanol, there are 2 moles of ethanol. In presence of base sodium hydroxide, it will undergo aldol condensation, and what will happen? It will produce beta hydroxyaldehyde. Okay, this beta hydroxyaldehyde is known as aldol. Why this name aldol? It is because alt represents for the CHO aldehyde group and the ol represents for the alcohol group. Okay, because of this aldehyde and alcohol groups present in the same compound, this is known as aldol. Okay, so this aldol, on heating, it will remove the water molecule. How? This hydroxyl group plus the hydrogen atom, it will remove a water molecule minus H2O. So what will happen? There will be a double bond formed in between alpha beta carbon atoms. Okay, a double bond is formed. So this is the final product of aldol condensation, and this compound is known as alpha beta unsaturated carbonyl compounds. Alpha beta unsaturated carbonyl compounds. Okay, so this is aldol condensation. Now we can look at the mechanism of aldol condensation step by step. So what is happening? Firstly, this is a ketone. Okay, we are explaining using a simple ketone RCO, R1CO, CH2, R2. So there is an alpha hydrogen, right? There are two alpha hydrogens, so we can consider any of this. A base, so this is originating from sodium hydroxide. So we had explained sodium hydroxide. So the base comes and abstract this alpha hydrogen to form water molecule, and as a result of that it will produce enolate. Okay, enolate. What is enolate? This alpha just hydrogen atom is removed, so H plus is removed, so there will be a negative charge on this carbon atom, alpha carbon. Okay, so this is enolate ion. So first step is the formation of enolate ion. Okay, what is the second step? Attack of nucleophile, nucleophilic attack. Okay, what is happening? The enolate which formed can act as a nucleophile because it is electron rich, so it can act as a nucleophile. And we know the carbonyl carbon is polar because carbonyl carbon has a partial positive charge and partial negative charge due to the electronegativity difference between carbon and oxygen atom, because oxygen atom is highly electronegative. So these carbonyl carbons are polar, right? So as a result of this nucleophilic attack, it will produce alkoxide ion. So how it is forming? So we can look at this, the carbonyl carbon which is polar because of the electronegativity difference between carbon and oxygen atom. This will have a partial negative charge and carbonyl carbon will have a partial positive charge. So we can write like this, CO with a partial negative charge and carbon atom with a partial positive charge. So the nucleophile, which is the nucleophile enolate ion, that can come and attack this carbonyl carbon. So what is formed as a result of nucleophilic attack? Alkoxide ion is formed. Now what is the next step? Protonation. What is protonation? Abstraction of proton from the medium. It will abstract the proton and produce beta hydroxy ketone or beta hydroxy. If it is aldehyde, beta hydroxy aldehyde. If it is ketone, it will produce beta hydroxy ketone. Okay, this is the reaction mechanism. You can check one example. Okay, take a simple, so I'm just taking a simple aldehyde, CH3, CH2, CHO. So there is alpha hydrogen, so it will undergo Aldol condensation. So first what will happen? On reaction with the base, it will produce a corresponding alkoxide ion. So CH3, CH minus CHO. So it will abstract the proton from this alpha hydrogen, from this alpha carbon. So it will produce an enolate ion. So now enolate ion CH3, CH minus CHO plus another aldehyde CH3, CH2, CHO. The same aldehyde in Aldol condensation, the aldehydes will be same. Aldehydes or ketone, whatever it is, it will be same. 2 moles of the same compound. So it will attack at the carbonyl carbon. So we can separately draw this carbonyl carbon. You can draw like this. Double bond OH. So here it will attack this enolate will attack at this position. So a carbon-carbon bond is formed. We can draw that carbon-carbon bond. CH3, CH2. We can just draw this aldehyde first. CH3, CH2, CO minus and hydrogen atom here. What is the fourth group? The carbon atom of this enolate, this alpha carbon, that will be attacked at this position. So what is the rest? CH, then CHO group, and what is the CH3 group, right? CH3. What is next? Now this carboxylate ion will abstract a proton from the medium and it will produce CH3, CH2, CHOH and CHO and this CH3 group. Okay, CH3. So this is beta hydroxy aldehyde. Okay, now which on heating it will produce alpha beta unsaturated carbonyl compound. So what will be this hydroxyl group and this hydrogen atom will be removed. So it will produce CH3, CH2, CH, double bond, C, CHO, CH3, right? So this is alpha beta unsaturated aldehyde, right? So this is the product of this reaction. Now, what is the difference between aldol condensation and cross aldol condensation? In aldol condensation, the aldehydes or ketones which undergo the reaction will be same if aldehyde is undergoing then 2 moles of the same aldehyde. But in cross aldol condensation, the aldol condensation is happening in between 2 different types of aldehyde or 2 different types of ketones, or in between an aldehyde and ketone. Okay, that is cross aldol condensation, and the conditions are same. What is the condition? There should be an alpha hydrogen and there should be a base. Okay, so if there is a base and alpha hydrogen, it will undergo cross aldol condensation. And if both of the aldehyde or ketones which undergo the condensation reaction has alpha hydrogen, then it will produce totally 4 products. How these 4 products are formed? The first 2 products are the result of the simple or self-aldol products. Means that this aldehyde, it can undergo condensation, right, and produce the corresponding condensation product, and this aldehyde undergo condensation and produce the corresponding condensation product, that is simple or self-aldol products. Now this aldehyde can act as an inolate and attack this aldehyde and produce one product, or this aldehyde which can act as an inolate and attack this aldehyde and produce another condensation product. Thus these 2 products are cross aldol products. So totally there are 1, 2, 3, 4 products for cross aldol condensation if both of the aldehydes which undergo condensation reaction have alpha hydrogen. Okay, now look at this CH3CHO, which on aldol condensation will produce CH3CH double bond CHCHO. Now aldol condensation of CH3CH2CHO, it will produce CH3CH2CH double bond CCHO CH3. And for all this, the mechanism is same, just the aldehyde or ketone is just changing. Okay, so that is cross aldol condensation. So I hope this concept is clear, so we can wind up here. So make sure rewatch this video if needed, practice the concepts, get fully comfortable before moving on. If you are a class 11 or 12 NCERT student and want complete materials, notes, tips, tricks or live classes, one-on-one sessions, visit our website or contact us through the number. Check the description box or comment section for more details. If you found this helpful, don't forget to like, share and subscribe and turn on the notification bell. Thank you for watching. See you in the next video.